Let's get started. Let's talk about descriptive statistics. Let's begin by reviewing what is statistics. Well, statistics is the study of how best to collect, analyze, and draw conclusions from data. So you collect data, you analyze it, and draw conclusions. So it's really a fundamental process common to many fields of study. In fact, all scientific fields of study will involve some aspect of statistics defined in this general way. Modern statistics, it's a pretty new field. It really only developed in the early 20th century, but the foundations lie much earlier, especially when we talk about the foundations of probability and the foundations of just analyzing data and collecting data through empires have long collected data on its population in order to expand its empire. The census developed in part through making sure that a empire or a city-state could recruit people to fight in wars and to make sure that the population is reproducing so that the empire or city-state can grow. So statistics has its sort of a long history, but the modern field of statistics is really pretty recent. One way to think about statistics, you can view it in the context of a general process of scientific investigation. So first you identify a question or problem. You might say, okay, what's the average age of people living in Germany? Then you might collect relevant data on the topic. You might collect census data for people in Germany asking their ages, or you might collect a random sample of people from Germany and then asking their age. But the idea is you just collect relevant data, you analyze it, you might calculate the average, you might calculate another measure of central tendency, such as the median, and then you make a conclusion. So you might say, well, the average age in Germany is some number, let's say 45. That's a general process of statistics. But statistics is in particular focused on making steps 2, 3, and 4 more rigorous, reproducible, and reliable. It's about making these steps transparent so other people can look at and reproduce what you've done. Identifying a question or problem, that's more related to a substantive area of interest. So for example, in the social sciences and humanities, people in psychology, they have slightly different questions than people in sociology or economics. And that's why sometimes you'll see statistics kind of branch off into substantive areas like econometrics, sociometrics, psychometrics, biostatistics. These different fields or subfields of statistics are really, there are slight differences in terms of what kind of question or problem you're orienting towards. And that will, in some cases, alter the focus of what kinds of analyses you conduct. But in general, all of these subfields of statistics are related in the fact that once you identify a question or problem based on substantive interest, you collect data, analyze it, and make a conclusion. So statistics has these two big branches, descriptive statistics and inferential statistics. Descriptive statistics is about taking a set of data. That data can either be a sample, it doesn't even have to be a random sample, but it's just some sample, or it can be a population. But the idea is you just try to figure out what's going on in the data itself. How can you characterize and analyze the data? Well, that's descriptive statistics. Right? Descriptive statistics entails presenting data, so you might look at tables and graphs. So here we have a scatter plot. That's appropriate when you have two numerical variables and you're kind of interested in how they might be related. You also can use graphs for bar charts for categorical data, to look at counts within certain levels of a factor or certain categories of a categorical variable equivalently. But the idea is a lot of statistics is about presenting data. It's also about summarizing data. So an average, it's a summary of a data set. It's a way to kind of characterize the center part of a distribution of a numerical variable. It's a way of saying this is the central tendency of a variable. You can also use the median or some other measure. In a similar way, percentage is another way of summarizing a categorical variable. The other branch of statistics is inferential. With inferential statistics, the idea is you take a random sample from a population to try to say something about that population. And there are really two sub-branches of inferential statistics: estimation, both point and interval estimation, and hypothesis testing. So estimating, the idea behind it is that you'll use some sample statistic to estimate some population parameter. So you might use a sample mean to estimate a population mean. Equivalently, you might create an interval estimate, right, to try to say something about a population. The other branch of inferential statistics is hypothesis testing. This is where somebody makes some claim about a population, and you use the random sample of data to test that claim. So somebody might say, I think the average height in a population is 72 inches. And what you do is you use a random sample of data to say and test that claim, and to either reject or fail to reject that claimed value in the population. So those are the two branches of inferential statistics. Right? The next sort of part when we talk about statistics is about all the different kinds of variables. So we collect our data in a data frame or data set. The rows are observational units, sometimes called cases. The columns are variables. And there are many different kinds of variables. These are characteristics of our data, of our rows, okay, of our observational units. So typically we talk about variables in terms of being numerical or categorical. Numerical variables are sometimes called quantitative variables. Categorical variables are sometimes called qualitative variables. The basic idea is that the reason this is important about saying, are these traits numerical or categorical, is that the kind of variable we have will alter how we present and visualize and analyze that variable. For example, we have different techniques of summarizing a numerical variable rather than a categorical variable. With a categorical variable, we're going to focus on tables and bar charts. With a numerical variable, we're going to focus on different visualization techniques such as maybe scatter plots or maybe a density plot or a histogram. In a similar way, how we summarize categorical data and numerical data differ. With numerical data, it makes sense to talk about a mean or median, or a standard deviation. With a categorical variable, where there are just 2 or 3 or 4 or some number of levels of a factor, equivalently some number of categories of a categorical variable, we might talk about proportions or percentages, but it doesn't make quite as much sense to talk about a mean or median. So we have different ways of analyzing these different kinds of variables. That's why it's important to think about whether variable is numerical or categorical. Within numerical and categorical variables, we often talk about subtypes. We're not going to focus as much on these, but these are also important. As you continue through statistics and learning more about data science and data analysis, these different types, these subtypes of numerical and categorical variables, they also suggest different analytical methods, different statistical models. So for numerical variables, we can talk about continuous versus discrete numerical variables. Continuous numerical variable might be, for example, just to give one example, your income, right? That's a continuous variable. Somebody makes $1,000.20 a month. Another person might make $422.38 per month. But we also can talk about numerical discrete variables. So educational attainment might be viewed as a numerical discrete variable. How many years of education have you attained? You might say, I attained 12 years, 13 years, 14 years. It's a numerical variable, but there are these sort of discrete values. We can also talk about categorical variables being nominal or ordinal. A nominal categorical variable, the ordering doesn't really matter. It's not informative. With an ordinal categorical variable, the ordering matters. So, for example, a nominal categorical variable might be religious affiliation. What religion are you? Okay? You might say you're Buddhist, you might say you're Protestant, you might say you're an atheist. But the idea is that there's no inherent ordering to those levels. That's a nominal categorical variable. In contrast, if you ask somebody, do you agree or disagree with some policy statement? And the scale or the different levels might be strongly agree, somewhat agree, strongly disagree, and slightly disagree. Well, that ordering that I just mentioned, right? It makes sense to order it in a certain way. In particular, the ordering that makes sense would be strongly agree, somewhat agree, somewhat disagree, and strongly disagree. That ordering makes sense for that ordinal categorical variable. So ordering matters for an ordinal categorical variable. For this course, we're going to focus more on the distinction between numerical and categorical variables, but keep in mind that there are these subtypes. Numerical variables, they have values that are numbers. To put it another way, it makes sense usually to add, subtract, or take averages of these values. So an age of a respondent, how old are you, the miles of gallon in a car, a ranking of a college. Is a college ranked number 1, number 10, number 500? These are all examples of numerical variables. Categorical variables, they have different categories or qualities. Sometimes they're called a factor, and the different categories are called levels. So gender of respondent is a common one. A lot of surveys will categorize people as female or male. Right? And that's a factor with 2 levels. The two levels are female and male. But a lot of attitudinal variables, do you approve or disapprove, or how much do you approve or disapprove of some policy? These are all examples of categorical variables. In statistics, we also have several major kinds of studies. Statistical studies are usually observational or experimental. An experimental study, we're usually focused on causation. Observational studies, we're just focused on description and prediction. An experimental study, there's some kind of intervention into the world. You try to see what happens when you give people one pill versus another pill. Right? There's an intervention, a change in behavior. Observational studies, they wouldn't do that. An observational study would just say, what kind of pill are you taking? Are you taking a pill? Right? It wouldn't try to actually change people's behavior. It wouldn't intervene into people's behavior necessarily. So the idea with observational studies, the goal is not causation or finding causation. It's about describing and predicting. Among observational studies, we can divide into cross-sectional, longitudinal, or sometimes called panel studies. Cross-sectional studies, it's just a single point in time. So a lot of polls, a lot of public opinion research or political scientific research, they're interested in, well, are people going to vote for a particular political candidate in one particular year, in 2010 or 1945? It's a longitudinal panel study, right? You track the same people over time asking them the questions. So you can see how people change over time. The disadvantage of longitudinal or panel studies, they're more expensive. Cross-sectional study, you get a snapshot in time. And there are other ways of kind of thinking about research design and different kinds of statistical studies, but these are the main statistical studies. And with that, we've covered sort of the basics of what statistics is about, the modes of research design, the kinds of variables, and the two main branches of statistics, both descriptive and inferential.